now what I want to do is go back to one of the examples that we did last time and go through it in a lot more depth. And instead of just using it as an example of what is a proof by contradiction, I want to use it as an example of how would you approach this problem and find a direction for a proof. So here's our more in-depth example. Claim is that the square root of 2 is irrational. Okay, so again, I want to keep pushing this idea of pay attention to the definitions and pay attention to what tools you can use to get access to these things. So definition. A number is rational if you can write it as a over b. So for some integers, a and b, and irrational if not. So if there are no integers a and b. Hopefully you can write down that negation and see what that means. So the tools that we have for these kinds of situations, well, writing x equals r over s, or I guess I'm using a and b, writing x equals a over b is a concrete thing to work with. Right? So that's not a very well thought out strategy, but the point is that that is a foothold to start going somewhere. So how can we decide what to do with this thing? So again, let's go back to what we were saying at the beginning with choosing what kind of approach we want to take. We want this proposition P, root 2 is irrational. So would we rather start with P or not P? So not P is saying root 2 is rational. And now if we look at the definitions and tools that we put up above here, this case, well, we didn't write anything down. I don't totally know of any good ways of working with irrational numbers. But here, well, this is not a lot, but it's a start. So this will inspire us to try a proof by contradiction. So we'd rather use not P, because then we have a tool. So proceed by contradiction. Okay. And here's another idea that I want to push. You should try to feel comfortable starting a proof without knowing where it's going to go. And by this, I do not mean when you are writing up your homework and exam solutions. This is what by this I mean like when you're trying to figure out what the proof is, which you will later write up. So when you're trying to work out a proof, feel free to just start. Just start and see where it goes. And if you can take one step at a time, then you'll often find that is enough. So let's start like that. Proof. Suppose root 2 is rational. So root 2 equals a over b for some integers a and b. Okay, now we're stuck. What do we do here? So I do also want to point out that there is no standard process for proving things. At some point, some creativity will be needed. But I want to point out a couple more things that might provide extra inspiration. So we have this rational expression. We're writing root 2 equals a over b. And let's insist that this expression is in lowest terms. So a and b have no common factor. We didn't need to do that, but it's a common thing to do. And the reason that you might want to do it is just because it gives you a little bit more to work with. So what do we have so far? We have this explicit, well, okay, we don't know what a and b are, but we have this at least a little bit explicit expression for root 2. We have a concrete thing to work with. And this gives us just some extra fact. So a and b have no common factor. A little bit more to work with there. And the final piece of inspiration, which is getting even more vague and even less obvious, but thinking about even versus odd, or divisibility by 2, might be a good idea here. Because if you think about, so let me say this in words and not write it down. Hopefully the sound outside is not too annoyingly loud. So why do we think this thing is irrational? So if we were doing root 4, that's 2, that's perfectly rational, no problem. What is the difference? The difference is that in this case, we somehow don't have enough factors of 2 to take the square root. We have the wrong number of 2's somehow. And this might lead you to start thinking about how does this, how do these factors of 2 affect the argument? Can this give us something to work with? And it can, and it does. Not in an entirely obvious way. But this might get you to start thinking about trying to see if things are even or odd. So in particular, not a and b are not both even. And now the proof is essentially going to come out of using this fact and just trying to figure out some way to get them to come together. So how might you do that? Again, here is something that isn't obviously going to be helpful, but is like maybe a step in the right direction. What if we take this equation and square it? So we can write if we take this and square it, we get 2 equals a squared over b squared. And this is helpful because we got rid of the square root. Again, I keep saying this, that like square roots are a little bit annoying to deal with. If you can get rid of the square root, maybe that helps. And now, maybe you see you can rewrite this as 2b squared equals a squared. And this connects back to what you were saying about things being even or odd, right? We can conclude that a squared is even, and by this thing that we've proved a couple times now, that implies that a is even. Okay, so it's still not obvious necessarily where this proof is going, but we did get something new. We got this new fact that a is even. So let's try and take advantage of that. How do we take advantage of that? Again, we'll use the definition to write a concrete expression. Write a equals 2k. Have I used k yet? I think we're good. For some integer k. And then, at this point we're getting closer. So maybe let's just finish this off. What do we do next? We sub this back into our expression here. And then we're cooking. Then you're cooking with gas. So 2 equals 4k squared over b squared. So 2b squared equals 4k squared. And let me actually I'm just going to go ahead right away and change this to b squared equals 2k squared. So b squared is even. So b is even. And aha! This is a contradiction, because we have concluded that b is even, and a is even, and also a and b are not both even. So I hope this is an example of, not every proof is going to be as easy as listening to someone explain it to you, but I hope this gives you some ideas, gives you some tips, gives you some inspiration for when you're looking at something that you want to prove. How do you get started? How do you take steps that will lead you in the right direction?